Well, good morning, folks. Thanks for joining us here, November 6th. My name is Brent Cook. I'm an exploration geologist, economic geologist. Used to write the newsletter Exploration Insights, which is now run by Joe Mazumdar. I was Rick Rule's analyst for about 4 or 5 years, which taught me what I need to know about winning and losing money in the junior exploration space. What we're going to do today is sort of a free-flowing session, and I want to introduce you to 2 companies and 2 people who are doing grassroots exploration in Wyoming and the basin and range. And I think this is important because they're looking for things that have not been drilled before, not retreads, etc. These are brand new ideas and concepts that really haven't been tested before. And they're going to go through the concepts, how they know what they're looking for, and that sort of thing. So I want to start off. I'll introduce Caleb Stroup. He's the founder and president and CEO of Headwater Gold Inc., an exploration geologist with 17 years plus experience in gold, base metals, and geothermal. His company, Headwater Gold, is actively exploring for a large portfolio of epithermal gold prospects in the western U.S. in partnership with Newmont, and they've also just got Centerra in as well. Sorry, Centerra. He's also the lead technical advisor to Red Canyon, a company exploring for copper in the western North America. He was prior senior geologist for Kinross Gold and has worked all over the western U.S. and Central America. The other fella today is Rob Bergman. He's CEO and director of Relevant Gold Corp. He has over 15 years of exploration experience across North America, exploring for basically all commodities. His first company, Big Rock Exploration, led the company through 10x growth before handing it off to the next generation of leadership. Big Rock is the premier North American exploration service provider with over 50 scientists working. He's based out of Minnesota, but works all over the western U.S. and I assume the Midwest as well. So with that out of the way, we're going to go through and talk about the current gold landscape, what major companies are looking for, because in reality, what we do at Exploration Insights and what these 2 companies are doing is find early stage prospective projects that will grow into a size large enough to attract a major or mid-tier mining company to come in and buy them out. I don't believe either of these 2 guys want to build a mine. At least I hope not. So we'll go through that, deposit types and such. So let me start off with you, Caleb. You've got a short presentation. Show us what you're looking for.
Sure. So I'll pull up a quick little set of slides that describes effectively the single type of gold deposit that we're focused on with Headwater Gold, which is called a low sulfidation epithermal vein system. These are very common in the western U.S. and globally as well. We're dealing with high-grade veins that are typically mined underground. Things that, can you guys see this all right?
Finally.
Finally. Okay. It was giving me a little bit of fits as it was popping up here. But yeah, to reiterate, we're focused on one particular type of gold deposit. These are high-grade epithermal veins, typically mined underground, but can be accessed open pit. But the key thing is they're bonanza high-grade vein deposits that have potential. And in many cases, the bulk of their value proposition is driven by the high-grade component. We're, as you said, working in the western U.S. with a focus in Nevada. And these are some of the highest grades and most profitable mines in Nevada. There's some very famous examples of high-grade epithermal veins: Midas, Sleeper, Aurora, Comstock. These are all household names effectively down here. And we think there's more to be found. But it is a fairly mature jurisdiction in Nevada. It's been explored for, since the mid 1800s. And that's really where this deposit model, in my view, shines. So I'll walk through the different components very quickly here and how this all sort of culminates in opportunity in the exploration space and what we're trying to pursue. So on the right, we're looking at the classic Larry Buchanan epithermal model. This is from the 80s and has changed in detail, but in aggregate still remains a very valid epithermal targeting model. The simple components here are, it's basically a hot springs type system. Think Yellowstone and geysers in the hot springs that are active there, that have hot water pumping to surface from depth, controlled by faults and fractures, and reaching the Earth's surface and turning into geysers and hot springs. Underneath that, there's a complex plumbing system, which is ultimately what we're looking for. That's where the high-grade gold deposits form at depth. And trying to put this whole picture together in a business case where you're looking to make new discoveries of high-grade vein systems, our approach is to look for the top of these systems, the sort of hot springs, remnant hot springs deposits that were made and left behind, but hadn't been drilled to the appropriate depth in the past to test for the high-grade vein features at depth. So in many cases, people had known about this model since the 80s, but had been targeting these things very shallow, especially in the last phase of exploration in the West, where 100, 150 meters was sort of the maximum open pitable economic depths. So what they missed, though, is all of these high-grade opportunities at depth. So I said we start effectively at the top of these systems. This is what I'm talking about when I'm talking about, a geyser type setting at the surface. This is one of the big geyser fields in the Yellowstone National Park with an active geyser. And critically, well, we can't see the geysers preserved because they happened millions of years ago, but what we can see is the evidence left behind. And you see forming around these things deposits of silica. We call this silica sinter. And this is a modern example of an active system. And just below it is an extinct geyser system in the remnant deposits that are left behind. So that's exactly what we look for out in the field on our projects, to say, okay, we're at the top of a geothermal system that has some potential at depth. Now, typically, this stuff at the surface won't have any gold. All the gold will have been dropped out underneath it. And that's where we're looking next, is about 100, 150 meters underneath this stuff. So there's a lot, I'm an epithermal geologist, and I can't get through any presentation without showing photos of sinter. But this is what this stuff looks like at surface. And this is from one of our projects, the Spring Peak Sinter deposit. There's many, many diagnostic features within here that I won't get into in detail, but you can see when you're in a setting like this, you're at the very top of the system. But as I already said, it doesn't have much gold. So why do we get so excited about these sorts of things? It's because it tells us underneath that depth, there's a good potential for high-grade vein formation. And this is what we're looking for, not necessarily the sinter for economic grades, but underneath it. There are veins that form in faults and fractures in a plumbing system that made it to surface. And we test for those by drilling holes into that target horizon. And when you're lucky, and I would argue good as well, you end up with core like this in the box. This is from our Spring Peak deposit, a new discovery we made a couple of years ago. You can see these beautiful banded epithermal vein textures, exactly what we're looking for. This particular sample ran about over 2 ounces per ton gold in a brand new vein discovery. And you can see by the smile on these guys' faces, they're fairly optimistic about that one as well. So this is what that looks like in a real world setting. everything I showed so far has been very conceptual in cartoon setting, but Spring Peak is actually, in my experience, probably one of the best textbook type examples of a vein system in reality. And the photos I showed you earlier from the Spring Peak centers are up here. There's virtually no gold at depth or at surface. But in our initial drill holes at depth, we banged right into a high-grade chute underneath with those veins I was just showing you. So that is a very simplistic version of what we look to do, is to find the tops of epithermal systems that have potential for high-grade gold, have structural feeders that we can target at the appropriate elevation, and then drill holes into them. And when you're successful, you end up with a picture like this with high-grade gold. And still, there's a lot I could talk about here in terms of, we're looking at a geophysical image behind it, which is one of our key targeting tools. But it all comes down to understanding that big picture deposit type, the scale of thing you're looking for, and if there was a high grade component, where would it be, and then go ahead and test that. So that's what we're attempting to do here, and having some early success with Headwater. And we'll talk a little bit more, I hope, about the business model and what we're looking to accomplish moving forward.
Excellent, Caleb. So how old are these things you're looking for? I mean, they're certainly not like Yellowstone. They're old.
Yeah. So it varies depending on where you're at in the world, and even where you're at in Nevada. But Yellowstone is active, and the photograph directly underneath Yellowstone in that deck was from a center that is on our Spring Peak, or sorry, our Midas North project, that's about 16 million years old. So it was very likely looked something identical to what we saw, what we see at Yellowstone. But in the ensuing 16 million years, it's been eroded and, complicated by other, deposits and features that deposited on top of it. But what we can see there is a big footprint that tells us there's an extinct system that could have, veins underneath it, just like at Spring Peak.
That's interesting. I know when I was working in Papua New Guinea, the Lihir Island deposit, which turns into 30 million ounces, that's only 700,000 years old. And a couple of the holes they drilled in there, they hit hot water and blew the drill holes out. So, you want a cool one, I guess.
Yeah, it's better if you want a cool one. Although if you have an active geothermal system, it's pretty cheap power potentially to run a mine right next door too.
Good point. So at the surface, you've got this big center of silica, and this thing will be maybe 100 meters wide or more. The only way you can really focus in on it, where the structure or the fault might be that's bringing this fluid up, is with some sort of geophysics. And that's what that image you showed depicted, was that red bit going down was the fault, basically, and that's where you expect it.
Yeah, there's a lot of different techniques you can use, and we usually use multiple different parameters in parallel, not just geophysics, but geology, geochemistry, other sort of alteration mapping and geologic mapping techniques. And what we look to see is, multiple different things pointing to the same direction. Okay, everything is pointing towards the center of this system being right here. And that's what happened in that image I was showing you with Spring Peak. Everything was pointing right there, and the geophysics showed a very, very compelling target that was really a no-brainer to go out and test that. Some of these are a little bit more enigmatic, where you don't have, due to various things. I mean, geophysics is geophysics. It's not reality. It's it's an attempt at modeling the subsurface parameters of the Earth from surface, and it's imperfect. Some cases it works better than others, like I was showing, but I think it's better to focus first on the geology. having a good solid understanding of the geology through mapping and alteration characterization at surface. And then when all of the other things point to the same direction, you're feeling pretty good about yourself.
Yeah, I think you're right. Boots on the ground is, in my mind, for grassroots exploration key, which I guess brings us to Rob. Um, you're looking for something quite different. That's what, 2+ billion years old, a piece of Canada that's ended up in Wyoming. What, you want to run through what you're looking for?
Yeah, you bet. I appreciate it. Thanks, Brent and Caleb. That was a great epithermal review, but I'm going to go way further back in the geologic timescale to the Archean. And I'm going to pull up my slides here and we'll kind of take you through it. All right. Should be able to see it now. So we're going after orogenic gold systems. Now, you'll probably hear this called a lot of different names. Orogenic gold is also known as Archean lode gold, shear-hosted gold, greenstone gold belts. These are all the same thing. They're all orogenic gold systems. And the reason we really like orogenic gold systems, and similar to Headwater, have focused specifically on these individual deposit types is because they are some of the highest grade, richest, and deepest gold mines in the Earth's crust. They've accounted for 1/3 of the global gold production globally. And so first here, we're just going to start out with getting an understanding of how they form, and that really guides how we navigate the exploration process in discovering these things. So first, you really need to think about it from a geologic timescale perspective. As I said, this is not just millions of years, this is billions of years ago, when the Earth's continental crust was moving and flowing, and your plates were really shifting those major plate tectonics around. And so the first thing you need is that mineralizing source fluid. This is going to be deep in the Earth's kind of upper mantle, lower crust, where you're really amalgamating your gold and precious metals and other metals in this solution. And ultimately, then you have your major, consider it mountain building events. When these plates smash together and the mountains we see today are formed, you get the second thing you need. That's that pathway. So this is the structure, the major fault, the belt scale features that tap all the way down deep into the Earth's lower crust, upper mantle, and allow those fluids to upwell along that major structural feature until they find the third thing they need for formation, which is that trap. Now, that trap is formed by these secondary structural features combined with the favorable rock types that are going to really cause that chemical reaction to precipitate out the gold. And in a lot of these orogenic systems, they're typically near vertical and can extend for many kilometers into the Earth's crust. There's actually numerous mines in orogenic systems that we've never reached the roots of that have mined for 100+ years. A prime example of an orogenic system in the US is the Homestake mine, that mined for 137 consecutive years, and it is an orogenic system. And again, never reached the roots of that system. So that's really how they form. And interestingly enough, most of the orogenic gold deposits are not in that primary structure. Consider that kind of your main river that's bringing all of these elements into the crust. And then they find those tributaries where they can kind of settle out in their eddies and work with the chemistry of the surrounding rocks to drop the gold out. So we're really looking for kind of these major secondary features coming off of these big belts. And the biggest orogenic endowment event in Earth's history was this kind of 2.6 to 2.7 billion year old event. This was by far the biggest crustal endowment of gold as far as we know it scientifically in Earth's history. And this is when the Abitibi gold belts in Canada were formed. So the Abitibi gold belts in Canada, this is the most prolific orogenic gold system on Earth. It's produced well over 200 million ounces in the last 100+ years. And it comes out of these kind of east-west anastomosing belts. So these gold lines on the map, that's your pathway. That's that major belt structure that tapped into those super deep, very high-grade fluids and allowed them to upwell into the Earth's crust. And all of these dots are major gold mines along those belts. So you can see how important that belt scale structure is to the formation of these deposits, and that most of these are within, 5-6 kilometers of that major belt feature along it. And you've got clustered camps of tens of million ounce high grade gold deposits. That brings us to Wyoming, because Wyoming and the Abitibi components of Canada were connected in that really beautiful endowment event 2.6 to 2.7 billion years ago. When all the gold came into both of these systems, they were still connected. And then it was about 500 million years later where you had your major plate tectonics that rifted off that southern half of the Abitibi and put it to where it is today, which is in present day Wyoming. And that's really where relevant gold was born, out of kind of unearthing this in the academic literature. This wasn't just a thesis. We kind of waved a magic wand and said, hey, there's going to be gold here. This is really standing on the shoulders of giants. One of our main technical advisors is one of the main academics who's published the science here, Dr. Kevin Chamberlain out of the University of Wyoming. And this tectonic reconstruction model had really opened up for relevant this tremendous overlooked belt scale opportunity throughout the Wyoming province. And that is really where our work began in kind of 2017. And similar to Headwater's approach, we've been very systematic in collecting all of the data we need to discernibly focus our drill dollars, as they're the most expensive, into some of these new discoveries that we're seeing across these belts in Wyoming. Really checking the technical boxes. So this is going through not only that structural setting that we talked about, but the favorable trap. That's the host rock. These are iron-rich and carbonate-rich rocks because the gold likes to react with that. And then similarly, we start to look for the alteration, the geochemistry, and the geophysics as what we call kind of our trifecta of data sets: geology, geophysics, and geochemistry. And you start to overlay those, thinking about like a Venn diagram. And where they all overlay is where they're pointing you to go explore. And that's basically what we've done. And then, lastly, it's in Wyoming, which has been tremendously overlooked, but it's got a very clear navigable pathway for permitting and mine development, which we really like to take advantage of. So that's a little bit on orogenic systems, why we're going after them, and kind of the technical setup for driving the exploration process in our minds.
So one thing that strikes me is, okay, the Abitibi has been worked by prospectors since people first got there. Yet, to my knowledge, hasn't been much gold mining in Wyoming. There's a few, but why do you think that is? Is there a difference, or why?
Yeah, so there's a few differences, and I think the key thing is there was actually a lot of historic high-grade orogenic gold mining of these systems. All of our projects, we see these high-grade orogenic systems. There is actual historic mining. Most of that fizzled out by about 1910, typically because the cost to mine during that mid to late 1800s gold rush was a lot more affordable and economic in Nevada, California, other states. And then we since have seen large companies out there doing exploration work. Newmont held a big piece of our land package in the 80s. Hecla as well had a very large land position along these Archean belts. And then but didn't ever drill them, right? So we got some of that data through some of our patent deals where we've got some soil geochem and things like that. And then I think the big component is really the scale. Wyoming, we've known about these occurrences, we've known about these old historic gold mines, but it was really this connection to the Abitibi that has opened up this prolific scale opportunity across these belts. And for us, we saw that as kind of a playground of overlooked geology. And we see that every day we put boots on the ground and do mapping work where the map is not what it seems, right? The work that's been done was at a resolution that doesn't allow us to necessarily vector properly for orogenic systems. So we've been building that data set, and we're getting really positive results. But I think largely the thesis didn't really catch a head of steam until kind of that 2005 through 2015 era, where a lot of the age dating, tectonic reconstruction modeling and things became a lot more confident. And since we've seen numerous new publications, they just put another one out with the Abitibi-Wyoming connection in late 2022, for example. So I think it's an advancement of that research and that work that's also opening up Wyoming in new ways.
All right, so what are you seeing or what do you need to see at surface to convince you to continue working on one particular project and bringing it to the drill stage? And then what do you need to see in the drilling to confirm your thesis
Yeah,
in,
so
in less than 4 minutes?
yeah, so goal, really what we're thinking about is grade. We like high grade. High grade in orogenic systems carries you through the down cycles. Scale, we're always looking for something of truly significant scale on a global level. So, the term district scale is used a lot. In our case, we're looking for, when we say district scale, we're looking for systems of equivalent size and scale potential to the largest known orogenic systems on Earth. So consider that footprint, a couple kilometers of width by multiple kilometers of strike. Those are what it takes to fit and pack in millions of ounces. So scale, grade, and then the alteration and geochemistry is critically important in our systems because it's telling us where we might be in the vertical zonation of an orogenic system. So when we combine those things, that's what we're looking for. The structure is the main driver of orogenic systems. So for us, when we drill these, we're looking to see those structures continue deep, because if they don't and they're shallow late structures, there's low likelihood that they could host a significant deposit. And then from there, it's gold grade. There's no better way to find gold than finding gold. But in the absence of gold, we look for our vector element geochemistry. Arsenic, right? You have a lot of pyrrhotite, arsenopyrite, and pyrite associated with orogenic mineralization. So we look for those vector elements at depth and of scale, right? We want truly mineable thicknesses, which is where high grade vein systems can get tricky because you need that actual scale to make it economic in the long run.
Right. So you've got, I just, when do you start drilling again?
So we just wrapped up a small 1,000-meter program at our Burr target. So never drilled before. It's about 4 kilometers step down from where we drilled last year. And last year we intersected kind of widespread oxide gold mineralization. We only had one hole kind of get into below the oxide zone. So this year we stepped down and poked some holes into the highest grade, underneath the highest grade historic patent mines. And we're expecting those results in the coming month.
All right. So what do we need to see as investors in your next batch of drill results to tell us either you're succeeding or not succeeding? I mean, what does success look like?
Yeah, really, it's the structure. So we want to see that structure below 100, 200 meters of vertical depth and of size and scale that we're seeing at surface or bigger. So anywhere from 3 to 30 meters wide of our main mineralizing structure. And then we want to see mineralization. It doesn't have to be the ultra high grade, but if we don't see the smoke, then we're not in the right place. So even some low grade gold mineralization with the right geochemistry is going to tell us that we're in the apex of this orogenic system. So what that looks like is what we saw up north. We saw 0.1 to 2 gram gold over our shear zones, across our shear zones, with dominant arsenic, antimony, bismuth, and tungsten. And so we're looking for that same chemical signature now along strike 4 kilometers to the south at this new target at depth. Those are the main vectors of success we're trying to achieve. Keeping in mind, the average orogenic system takes about 10,000 meters of drilling to really start to define what you're looking at. So we got the 1,000-meter program. We're looking for that geology and geochemistry at depth.
Okay. Let's get back to Caleb there. What does success look like to you? And just as important, how do you know when to, what's going to tell you to leave, to bail? Because I think one of the biggest problems we face in the junior mining sector is companies, geologists don't know when to quit.
Yeah, so I totally agree. And part of our fundamental strategy with Headwater is to take a portfolio approach and move through a number of different projects relatively quickly and have some pretty specific criteria for what you need to see to continue. And if you don't see it, move on to the next one. And that's in early stage exploration, to have any sort of meaningful probability of finding what you're looking for. You can't just fall in love with one project and keep banging away at it. So with the deposit model I described, we have a very specific target in mind, underneath an active or underneath an extinct hot springs type setting. Now, not all geyser type systems have a world-class gold deposit underneath it. That's just that's a fact. Isn't, you know, as it works out, a small percentage of them tend to. But if it's there, we know where it should be. So what we look to do is do the first tests of that high grade system underneath the favorable environment and see this, a couple of different criteria for whether or not this project has a chance. Obviously, if you bang into multi-ounce gold underneath the barren sinter, that's a great start. That's what we did at Spring Peak relatively early on. But in the initial scout program at Spring Peak, before we drilled the true discovery hole, we drilled a hole that had all the right vein textures, but nothing over 5 grams per ton in it. And we viewed that as a massive success. And Newcrest at the time agreed with us and signed, a significant $55 million earn-in agreement on the basis of those low-grade gold results, because it looked like everything you want to see for high-grade potential. Now, you don't necessarily need that high grade early on if you're seeing additional evidence that you're onto the right track. Like you might drill your first holes and say, this is looking better and better at depth, but we're still not to that boiling window. So one thing I didn't really get into is the mechanism for how gold gets dropped out in these epithermal vein systems. The hot fluids that are coming up those cracks at some elevation, driven by temperature pressure dynamics, boils and effectively turns to steam that vents to the surface. And in that process drops all of the gold that was in those fluids. And that occurs in a discrete window. And so unless you're convinced you're in that boiling, so I've drilled projects where it looks like you're in the boiling window and you're seeing the veins and textures you want to see, but there's no appreciable gold. That's a big red flag. It's time to walk away, because not all of these systems are capable of producing bonanza grades. Now, if you see, pretty good grades, like say, gram per ton to 5 gram per ton, but no bonanza grades, but you don't think you're in the boiling sweet spot, then you got to go find the boiling sweet spot. You still have actually your probability has increased significantly at that stage, because there's precious metals in the system, and you're onto the right track and you're closer than you've ever been. And so many times it does require a second or even third follow-up program to vector in to those sweet spots. But you also can't be too precious about that and keep going forever, because it's a capital intensive business exploring for really any sort of metal deposits, and you need to be able to walk away. And that's where that portfolio approach comes in. We can continuously balance a dozen different projects and allocate our resources to the ones that are showing us the best probability of success moving forward. We don't have to just hunker down and keep going on one project because that's all we have. We always look to upgrade our projects and move to the best ones, especially with our self-funded 100% funded projects.
All right, so I guess, here's the problem that all you junior explorers face is you drill a hole and you get 10 meters of, call it half a gram at 200 meters depth. You're encouraged, but that does nothing for your share price or, continuing the program. So, this is very high risk stuff and expensive to do. And it's, you're a scientist, you're doing science, real science. How do you go about mitigating that risk?
Yeah. Do you want me to answer this one?
Yeah, Caleb.
Yeah.
Then Rob.
So, yeah, our approach is that hybrid approach where we're scientists, but we're explorers and businessmen too. And, that's why we're in this game is, we have the entrepreneurial spirit. We think that we can create a tremendous amount of value through discovering new metal deposits. In a perfect world, I would love to do that, on a 100% funded basis. But the reality of the capital required to do this, and the reality is the market for junior exploration is relatively small compared to other things, and there's a limited pool of capital from the capital markets. So we look to augment that by accessing a slightly different pool of capital in the major mining companies. So these are ultimately our customers in the end. Our goal is to find a big high-grade gold deposit in a stable jurisdiction that a major mining company wants to come in and buy, hopefully at a premium. And they understand these systems. They understand what they're looking for. And so for the groups that, are aligned on those parameters, there's a pool of capital available, and we've been pretty successful at accessing that. We've got a couple of projects in joint venture earning agreements with Newmont right now, the world's biggest gold mining company, that came through originally a deal with Newcrest, where we put 5 different projects in earning agreements with Newcrest. Subsequent to that, we got Centerra Gold in as a 9.9% equity holder in a recent financing. And so I think, those people understand these gold systems. They know what an economic system looks like, and they can recognize the groups and teams that, have the expertise, the appropriate strategy, but also the ability to execute on the ground, which is a very important thing too, at a scale that a lot of these companies don't really have the resources to do on the grassroots early stage side themselves.
It's a process. It takes time and science, and you're not going to win automatically in 4 months, and that's what kills a lot of these junior companies. Jumping over to you, Rob. How are you mitigating risk in this really high risk exploration project?
Yeah, I think, echoing a lot of the same sentiment as Caleb, but access to capital. We've all known that for the last few years, that's been one of the biggest challenges for the junior mining sector. Both companies on this panel have had a very strong ability to access capital in these down markets. So what that's done is it's given us the ability to really move our entire portfolio. And these are, as we said, a portfolio approach. We now have 17 high-grade district scale targets identified. We've got some of those initial first phase geology drill programs into some of those with some incredible new discoveries and success. But it's really allowed us to spend the right amount of boots on the ground time before expending those drilling dollars. Now, why is that important? Because drilling is the most expensive part of the process. It's also the most definitive part of the process. So once you start drilling, you start to be able to more confidently check, I guess what we would say are the negative exploration boxes, the what do, if I see this, should I walk away boxes? Because I think it's equally important to have those criteria as it is to have the criteria you need to find the big deposit, because that helps, at least going into it, it helps stop you from drinking your own Kool-Aid once you're in the actual guts of exploring. Just go back and say, okay, you know what, we said if we encounter this, then there's no way this could likely turn into a big thing, and we need to drop it. So negative exploration, I think, is equally as powerful as positive exploration. It allows us to drop ground we don't need, minimize our burn rate, our overall costs. But I do think one of the most critical components in mitigating risk for early stage explorers like us is doing the right amount of front end work to focus your drilling efforts. Sure, Caleb mentions luck in the Spring Peak drilling program. There's a whole heck of a lot of science and knowledge and data that went into driving them getting into a circle that could get lucky. So it's that, and that comes from that systematic approach. And I think that the groups that have been able to take advantage of putting that effort in while the markets have been subdued are the ones that are now poised to drive through multiple potential new discoveries in a rising gold environment. So I think, you know, mitigating risk comes from high quality boots on the ground work on the front end for early stage explorers, so that you have a focus to your drilling dollars when you start to spend the more, you know, expensive capital.
Right. And who's been financing you up to now?
So we've got a very unique shareholder base. You know, myself and co-founder Brian Lentz were some of the biggest financiers of our company. But in addition to that, we recently got Kinross in as a strategic. They came in and took a 9.9% position in July. We've got Rob McEwen, New Gold, and a number of other ultra high net worth folks. And that's really helped us, because not only from the major miner perspective, as Caleb was mentioning, but just having sophisticated capital behind you that understands the process, right? Understands that it's not a 4-month process, that it does take time and it takes resources to actually be successful in the discovery process. And so I think, you know, that's what we've focused on, and we've got that unique kind of backing. But the partnership with majors, you know, the benefit that brings outside of access to capital is access to knowledge. You know, with the Kinross deal, for example, we've got a technical committee out of it. We've got folks that have a serious amount of experience studying Abitibi mines and deposits, and they get to bring that to the table for us as we look at our technical aspects related to developing our project. So I also think that's another benefit that those kind of partnerships and attracting major partners really adds to the value spectrum that maybe is often not attributed as much value as the access to capital, but I do think it's important. That's
a great point, and I think that's something both Joe and I really appreciate in what you two are doing. It's one thing to get some money, but it's a much better thing to get the money from educated investors who understand the process. And you can't afford all the geophysicists and all that they have, but they're there for your use. I think it's fantastic. I've got no other specific questions. If there's anything you want to say last on your company before we open up the questions, that'd be great. Caleb, anything more to add?
Yeah, I mean, I think we've touched on a bunch of this, but maybe to summarize just a little bit. I mean, in my view, the critical path for an exploration, a grassroots exploration company, is to look for high-grade assets in a stable jurisdiction of the size and character that major mining companies want to develop into mines. If you're not doing that, if you don't start from those first principles, you're going to have way more challenges at every step along the way. And, what we've talked about these high-grade veins, but I think it's important to underscore how important grade is in the mining business in general here. And not only for us and for as a junior explorer and our market recognition for new high grade discoveries, but the second component too, that's what the majors are looking for. These sophisticated companies understand that a lot of the junior companies that you'll see come into the market in a high gold price environment are looking to pick up old retreads, as you said before, low-grade, past failed mines. There's a chance that those can work, but typically you need, basically all-time high gold values or gold prices to persist for, a decade or more while you get that mine into production. The major mining companies aren't necessarily willing to make that bet. They're looking to back stories that have the size and grade that they can mine in any sort of price environment and make money, and make a tremendous amount of money in a high gold price environment. But they mitigate risk themselves in that way, focusing on grade. So I think, implicitly both of us are focused on that grade first mentality for those reasons. You can really you'll get a multiple in value for a new high grade discovery, and a much quicker pathway to a potential exit because you'll have the buyers that are interested. And the key thing is there's zero inventory of high grade gold deposits sitting on the shelf in stable jurisdictions. So that brings me back to the early stage part of our business, where we recognize very early that, okay, if we want one of these things, we're going to have to go out and find it and figure out a way to build a business that, has the longevity to execute that plan.
Good
Yeah,
point,
Caleb,
Scott.
I agree with you, and I just want to echo the sentiment on grade quick. And for the audience, I would encourage you to look up this little thing called Archie's rule, and that's like a simple way to understand grade as it applies to mining deposits. And what Caleb's saying, and Archie's rule is pretty simple. It's to be economic, a mine must have a recovered value of 2 times the all-in operating cost. If you follow Archie's rule, you typically will live through all the down cycles. And the easiest way to achieve Archie's rule is high grade. And that's something that one of my mentors, Peter McGaw, has drilled into my head since university, was Archie's rule and the importance of high grade. So I just thought I'd throw that out there because people can look it up and understand there's some formulaic equation to the importance of grade.
Yep, that's entirely right. All right, Brennan, do we have any audience questions?
Just pulling some up now. Can you guys hear me?
Yeah.
Yep.
Okay, perfect. Okay. We have one right now that just popped up. What made you choose to explore where you're exploring?
Well, I can jump in first if you want, Caleb. I mean, for us, it's hopefully obvious. We see Wyoming as the new American Abitibi, and a chance to basically pioneer the opportunity there. We like to say, imagine if you could go back in time, with all the knowledge, the toolkit, technologies, the geologic models and understanding of the Abitibi, and apply those insights pre-discovery. That's exactly what we're doing in Wyoming, because not only of this tectonic connection to the Abitibi, but now we have some very good analogs and some very good models to help guide our exploration. But ultimately, we ended up in Wyoming because it's the right rocks and the jurisdictional risk component. It's one of the best places to operate in the world. And we're seeing that with long-term exploration permits and an expeditious path to mine development. So jurisdictional risk, echoing Caleb's point too, of that is important, like grade, in the sense of you can find a high grade big deposit, but if the infrastructure costs or the socioeconomic or political risks are too high, it still may not attract the big miners you need to develop something like that. So that's
I would agree. Yeah, with all those, so we're focused in Nevada, which is, a fairly straightforward value proposition. It's, premier world-class mining jurisdiction. And I think that speaks for itself, but the thing that we recognize right away is you need to develop a exploration model that has a reasonable probability of success in a jurisdiction that's been explored for a while. And so that's what we're doing, and we're focusing that model in the footprint of massive world-class gold deposits in Nevada. Several of our projects are, within spitting distance of, currently operated or past operated, high-grade gold mines with all the infrastructure synergies that could potentially come out of that. The stable regulatory environment of a true mining jurisdiction, and the right rocks are there. So I think it's, if you can figure out a plausible mechanism to make a new discovery in a great jurisdiction, as I think we have, I think those are still great places to look.
All right, Brennan, any other questions?
Yeah, we've got another one here. You mentioned you guys are near. There we go. Mentioned you're near past producing mines. How does that impact your decision and where you explore?
Yeah, I can take that one from there. So, we're looking for new standalone sort of world-class gold deposits first and foremost. But if you're, say, within 5 or 10 kilometers from a past producing mine with a mill sitting there on care and maintenance, your threshold for meaningful success all of a sudden becomes much smaller. Where maybe you don't find the 2, 3, 4 million ounce deposit you're looking for. You find a 1 million ounce deposit that, if it was in, the jungles of South America or in, high in the remote Canadian Arctic or somewhere else, might be very difficult to monetize and turn into a mine. If you're 5 kilometers away from a hungry mill, that's a whole different scenario. And 1 million ounces can have a tremendous amount of value and could be the catalyst to restart a whole, new generation of mining in a mature district. So I think those are really great setups that give you, multiple, a lot of optionality for multiple different scenarios to create value.
Yeah, I think in addition to that too, the other simple standard of gold is the best vector to gold. So, you can say the shadow, the head frame component, they're all common things, but the reason that applies is because, where there's gold, the elephant sized deposits, these very major deposits, they typically are clustered. They're, you want to be in those trends. And I think further to that, having past producing mines in the neighborhood is extremely beneficial from a data perspective and an understanding of what is that gold. Even if it's 5 kilometers over there, you can usually get data, you can usually get access to that information, and that really is going to inform a lot of what you may or may not want to see, right? Maybe that's a past producing mine because there was an economic hurdle it couldn't overcome. So how can you learn from that to say, well, if we see that, we need to be concerned? Or, so I think that's another component of that probably I know both Caleb and I would really think is valuable. It's not as textbook of a shadow in the head frame, but that data and knowledge is also a very important component to exploration.
Yeah, you immediately also have a working analog for a gold mine. So you say, okay, if it was a vein like Midas, which 4 million tons at an ounce per ton in a northwest directed structure down to the west at this elevation, okay, that gives you a lot of information to where to begin your search and what your probability of finding something big is.
We got one
Any-
more as well. Are you guys done? Sorry.
Go.
How important is geophysics when you guys are planning these drill programs?
I can go first if you want, Caleb. Geophysics, and Caleb touched on this in a polite way, but to say it simply, geophysics is geomagic until it's tied to something physical as far as the rock characteristics, in my opinion. So I think geophysics is an outrageously powerful tool for exploration. It's a must use in today's environment, but you certainly need to understand what the geophysics is telling you, because it can also produce a lot of shiny red things that look like you should go drill them, but it maybe doesn't have the full breadth of technical criteria for a high grade deposit to be there. So for me, geophysics is like one of the most essential and critical tools that's powerful, but it's only as good as the actual physical characteristics that we can tie it back to. And sometimes you don't get that until you start drilling, and then the geophysics maybe makes more sense. But yeah, that's my quick response.
Yeah, so echoing what you said there, I mean, we use a lot of geophysics What we don't do is apply sort of a cookie cutter approach and say, oh, we got a new project, we got to do magnetics, gravity, CSAMT, IP, all this stuff, and then find a red blob and drill it. We apply specific tools to specific exploration problems, so there's several projects that we've drilled with zero geophysics because the target was fairly obvious from the geology, and we had a great concept of what we were aiming at, and we didn't need the geophysics. It's much more common, frankly, that you get a pretty good picture from the surface of what to expect, and then before you expend the capital to drill it, you can do an initial test of that concept with low-cost geophysics to say, okay, well, let's do some CSAMT as an example, and if I'm right about this, I expect to see X or Y, and if I'm wrong, it would look like this, and use it as a filtering tool rather than a standalone target generation tool. I think that's the key thing.
Yeah, I'll give you an example, Caleb. On our Lewiston project, for example, we ran detailed ground mag, and it really highlighted the structures, right, that we think the gold's going to be in when we drill. But, a lot of people would have ran maybe IP, MT, a number of other expensive geophysical surveys. We drilled the small 1,500 meter program into it because it's oxidized at surface. So we didn't know what our sulfides were, what they're made up of. If it's pyrrhotite, it might have a slight magnetic signature. If your orogenic veins are dominated by a sulfide assemblage, then IP could really be applied. So our initial drill program identified that we do have this beautiful sulfide assemblage associated with our gold. So now the idea of going back and running an IP survey is actually going to get more value for our shareholders because we know what it is actually telling us.
Yeah, just as a general comment for you folks listening out there, I have yet to see a geophysical survey that didn't turn up some sort of anomaly. And what I've also noticed is that anomaly is generally just offset from the most recent drill hole. So I'd take all that with a bit of caution. Anyone else out there got a question?
You may have already answered it, but it's are these epithermal veins sulfides?
So a lot of the gold that's carried in most of these epithermal vein systems is either in free gold or a mix of gold and silver, or within some sort of complex sulfosalt type mineral. The grade that we're looking for and expecting, say greater than 10 or 15 grams per ton, makes it such that the metallurgy is typically less important than sort of an open pit heap leach type operation where the recovery on those matters a tremendous amount. If you got 15 gram per ton veins, that pays for the grinding and milling and extraction of that gold in almost every case across the world. So you don't typically have to worry quite as much about the metallurgical makeup of these if you're focused on the grade. Another example of grade solving problems. You don't have to worry about, do we have 62% recovery or 69% recovery? Because 62 isn't going to work, 69 is. It solves a lot of those problems.
So I think we're coming to the end here. And any last questions before we leave? But we're ending the webinar now. Brent, if you want to take over and do some finishing remarks.
Yeah, well, I hope this was useful to the 821 people online here. I assume this will be posted on both of your websites once it's put together, and we'll also put it on Exploration Insights website, where I'll make a plug here. There's a lot of other information there that I think might be useful for people investing in this sector. With that, thank you all for joining, and all the best.
All right. Thanks a lot, Brent. Rob, it was great.
Thanks, Brent, Caleb, and everybody tuning in. It was fun. Look forward to doing it again sometime.